Okay, so now we're going to do a derivative proof involving the square root of x. Again, this question says, what is the instantaneous rate of change of x at x equals 5? Excuse me. That just means the derivative. We're going to be proving this using the difference quotient, which we learned before. So right off the bat, we are going to write out our difference quotient. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Again, if you haven't watched that video, you need to watch the video on the derivative explained, okay, the definition of the derivative explained, or the difference quotient explained. Okay, so again, just like when we did the proof for x squared, okay, now we're going to do square root of x, but we still need to determine f of x plus h. So every time there's an x in the formula, we're going to replace it with x plus h, which means f of x plus h is equal to square root of x plus h. So x is just replaced with x plus h. Simple, right? And again, here's our f of x. Here's our f of x plus h. We're going to plug that stuff into the formula. So we're replacing f of x plus h with square root of x plus h. We'll replace f of x with square root of x. So here is our derivative formula. And again, the whole goal is to get rid of the h on the bottom. Now, when you're dealing with square roots, the thing you have to do is you have to end up multiplying by the conjugate, which means the same expression, but the sign in the middle is flipped. So in this case, we'll be multiplying by this this expression, but we'll change the minus to a plus. That, in effect, will lead to the cancelization of an h, which is what you want. So I know there's a lot going on, but again, like I explained, we're multiplying the top and bottom of this fraction by the conjugate of this expression. So that means we need to FOIL it out, right? So first term times first term times last term right here, middle terms multiplied together, and finally last terms multiplied together. But if you know anything about conjugates, you'll know that the middle terms will cancel, or the O and the I in FOIL cancel, and because it's plus this minus this, it's the same thing, it just cancels out. You're left with the first terms multiplied by each other minus the last, or plus or minus depending on the sign, but I guess it would be minus, wouldn't it? It'd be minus the last terms multiplied by each other. So you have square root of x plus h times square root of x plus h minus square root of x times square root of x. And notice, though, you had to do that to the bottom. So on the bottom, you're going to have h times that conjugate. One of my students tried to distribute the h in. You don't want to do that because you ultimately want to cancel this h. So go ahead and leave it like that. So now what do we do? Well, the square root of anything times itself basically removes the square root because you're squaring it. Same goes for both of these. So it just becomes x plus h minus x. Okay? And now that we see that, we see what? We have a plus x and a minus x. Those are going to cancel. And now we just have an h on the bottom. Going back up here, some of you may be confused because it goes from one slot to the other. But again, square root of x plus h times square root of x plus h is just x plus h, which is where we get that. And then the square root of x times the square root of x is just minus x. So the x's cancel. We're left with h on top and h on bottom. That leads us to the next step, which is cancel an h on the top and bottom. So now these h's cancel, and you end up with a 1 on the top. And now, just like with the previous proof for x squared, we can now plug in 0 for h, and we won't get a 0 on the bottom. So when we plug in a 0 for h, we get 1 over the square root of x plus the square root of x, which ends up being what? 1 over 2 square root of x, because there's 2 of them, right? And so again, this gives us a formula for the derivative of this function. If we wanted to figure the derivative at any x value, we could then just go ahead and plug that particular x value in. And again, this is for our original formula, which is f of x equals square root of x. So now that we have this formula, we can plug in virtually any x value. In this particular example, though, they're asking for the derivative of x equals 5. So we'll plug in 5, but you could plug in any number, and it would give you the derivative at that point, which again, what is the derivative? It's kind of like the speed of the function. It's its change in y over its change in x. So now we just plug in 5 for x, and notice basically this one takes care of itself. X is going to be replaced with 5, and your final answer is going to be 1 over 2 radical 5, which means f prime of 5, which is what you were originally figuring out, equals 1 over 2 radical 5. And again, remember, f prime of 5 means the derivative at x equals 5. So we're going to be using this notation more and more in the next few examples. And we're going to move away from that terminology of instantaneous rate of change, although you'll continue to see it as the year progresses. Let's take a look at the graph of this function. Okay, so here's our graph of f of x equals square root of x. We've got it typed in up here. And notice that when we drag this point, this green point, all the way to the black point, we see our change in f of x is approaching something. It looks like 0.22222. And as h becomes 0, the tangent line is drawn. And we see that the derivative is something like 0.22361 is the slope of that orange line, okay, which we found to be a derivative. And it turns out that if you type in our answer for the derivative, let's see if we can get back over here, 1 over 2 radical 5, you will indeed get 0.22361, the slope of that line. So this just confirms the fact that derivative at x equals 5 of square root of x is equal to 1 over 2 radical 5, which as a decimal turns out to be f prime of 5 is equal to 0.22361 approximately. That's it for the derivative proof of the square root of x at x equals 5. If you have any other questions about this derivative proof, let me know.